Hello, I'm Joe Dillette. In this video we're going to look at the practical example of when wood moves, how to design for its movement. Previous videos I discussed why it moves with moisture, how much it moves with moisture, and I recommend you look at that. And then let's look at just how it affects the carving over a period of time, this movement of wood. So we're using the numbers again out of this here book, the Fine Woodworking book on wood and how to dry it. Let's look at some carvings. So many of the small carvings like this, made from one piece of wood, very little movement, all one piece of wood, the same species of wood, its movement is negligible, and this is not something you need to worry about. Also, carvings like this. This is basswood again. It will be moving. It's like the fibers in the wood is expanding and contracting, the bundle. Again, it doesn't change for length, only on the width. In a carving like this, now this is basswood. Basswood moves about 0.28 inches per foot with a 13% moisture change. That's in the plane sawn. This piece here is plane sawn. So this piece here is going to expand and contract about 1/4 of an inch, maybe a little bit more from summer to winter. And again, is not negligible. It's free to expand and contract, to move up and down, and that 1/4 of an inch won't be noticeable. There's nothing holding it, so it won't split or crack. It's free to make its movement. In this piece now, we have to be a little bit more careful. This is also basswood, and black walnut is what the cross is made out of, and the grain is changing direction. So the body of our Lord here, from shoulder to shoulder, the grain is going this way. So it's moving in and out. Now the grain on the arms are going along with the grain. So this will not change in length. But what changes in width here, this is about 6 inches across. So we're going to get about 140 thousandths, about 1/8 of an inch movement in this body width. Now these hands are fastened to the cross. The black walnut, the grain is going this way, so it will not change in length from its 2 points that are fastened. So that 1/8 of an inch is going to be putting a little stress on each of the mounting places. I didn't glue it hard in there, so what I did is it's pinned in there. The pin is going to allow a little bit of movement, so it should be fine. It should create no cracking in here. What you would expect it to happen is, because the strength of the wood is strong here, because the grain going this way, that it may crack here by the joint. This is not going to crack because it's going to pick up that little bit of movement off the pins in its mounting. The larger you get in the carving, the more movement you're going to have. Now this particular one is also basswood. We're using basswood as an example here. So this is a little over, it's about 18 inches, a little over 1.5 feet. So this is going to change about 400 thousandths, over 3/8 of an inch. So in the summertime, this thing will be about 3/8 of an inch higher than in the wintertime. So it's shrinking and expanding depending on moisture. It's not going to change for length. Now this is all done from one solid block of wood, so it's going to all move together. This one was done quite a while ago, probably about 10, 12 years ago. No cracking. Wouldn't expect it to crack because everything is allowed to move, expand, and contract without anything holding it back. I've got some examples that we're going to look at. I'm going to go on location, show you some larger carvings that I did. where some cracking did occur, and then another carving where I compensated for the cracks by expansion joints, and how I used those expansion joints. The expansion joints I used on a carving that's 32 foot long. The other one is 6 foot, and I thought the framework would allow, because the frame is mounting it and the carving is loose in the frame, and I thought it would expand and contract, but it bound up because the frame also, because the wood expanded and it pinched against the frame and it didn't allow it to move sufficiently. So I did get some cracking on the one, and that was my mistake, and I'll show you that also. Here is a carving I did about 30 years ago. It commemorates Pope John Paul II, his first visit here to the United States, the first time a pope set foot on this continent. Anyway, this is about 6 foot long. It's made out of pine. We were talking about the wood expansion and contraction. And this was a mistake that was made, that I made when I did not plan well for the expansion and contraction. You see the cracks. What I was hoping would happen is the carving is floating in here and the frame is what's holding it. So this is an oak frame and pine. I was hoping that it would expand and contract inside the frame. But when we mounted the frame, it was too tight to the wall. And it didn't crack until about 10 years ago. For about 20 years it didn't crack. They put a heater in here. This is in the vestibule. And they put a heater and just to warm up the vestibule. And the heater blew on here and dried this wood way out, more than it should have. And that's where the crack started. Right now you can't fill the cracks with anything other than something soft like a beeswax, because in the summertime these cracks all close up. Wintertime they open, summertime they close. This is a practical example of planning for expansion joints so the carving doesn't crack. When I initially was designing this carving has been up about 20 years. But when I was initially designing it, I was thinking about putting the expansion joints, hiding them along the profile. So then it would run up through here. That would maybe try to hide them a little bit. But I thought that would be a bad idea. I carved the sample and it looked like it was a weak spot and looked like it broke. So then people would be coming to me and saying, oh, your carving is cracked up there. So I decided to do the expansion joints in straight lines so it looked like it was planned for. It was planned for. Before the carving was done, I told them how much that each crack was going to open in the wintertime, and in the summertime it closes up. A couple things that are kind of unique about this carving. It is curved. This whole wall is curved. So the hardwood connection helped me with getting the wood. The hardwood connection supplied all the wood. They did all the laminating. So the laminating of this was done in sections. So this part here was thicker, and I drew up a plan where they would put all what thicknesses in what areas. They machined the back of these panels so it fit the radius of the wall. The radius of this wall is in the center of the auditorium. Everything is around it. The auditorium is like a silo. This is the Farm Bureau, so they made the auditorium like a silo. And all the radiuses in this building come from the center of that silo. Gave them a template of the curve of the wall. They did all the mounting strips. They helped me with the mounting. They did all the laminating, and helped me install it here. So in planning for the expansion joints, the major expansion joints are behind the trees. So the wood is not touching behind the trees. The trees are fastened on above the carving, so over the top of the carving. So as we move in, what we wanted to do is divide these panels up, the expansion. So right next to the tree here, we had this panel here was fastened, so this point here wouldn't move. So all the expansion of this panel then is behind this tree. Then the panel next to it, there's 4 panels in each section. Then this is divided up so the cracks, the expansion joint here and here would end up being even. So right about here is where it doesn't move, so most of its movement is in this direction and about half of its movement is in this direction. So that, and we did the same on the other end. So on this end here we have with most of the expansion is behind the tree. Over here this is fastened solid, so this point here won't move right here on this side. And all the movement for this one is done on this section right here. And so to make that even and in the middle, we went about 2/3 and we fastened that panel tight. So all the mounting is done from the front with plugs. And the plugs, we matched the grain. There's 144 bolts in the front. And where we needed the panels to move, like under this tree, then the mounting here was done with slots. So there was a slot in the mounting hole that would allow the panel to move, and how we kept this side rigid here was the hole, the mounting bolt was round so it wouldn't move here. So all the expansion is done on the other side. Total work is 32 foot long, and each of the 3 sections is made up of the 4 panels. In the summertime, now we are right in the winter time, this is the driest that this building gets. There is no humidity control in this building, so this building gets very dry. We had to plan for these expansion joints open up very much. I didn't want it cracking like the other one. This has been installed about 20 years and it's holding up quite well. And as I said, all these expansion joints, although they seem to be wide right now, they will close up tight in the summertime when the humidity is high. So this is the 3 seasons of farming. You have the spring planting, you have the summer, and you have the harvest in the fall.